finally, after 3.5 years of being non-profitable, we can now make a board that can compete with plywood.
Just a quick reminder for you to like, subscribe, and rate this podcast so we can get your feedback and know how to make it better.
Hey, it's Ari. Welcome to another episode of the Made in America podcast. Today, I'm with Tom Kelly, owner of Kelly Green Products. Tom, thank you so much for coming on today.
Hey, thanks for getting me here.
It's our pleasure. Tom, it's the Made in America podcast. So we're going to start off with the same two questions. What do you make and why do you make it?
We make a board out of trash. We take juice cartons, milk cartons, and we shred them up with plastic bags. We make a slurry of shredded products, and we put it between fiberglass and craft paper, and we heat press it into a construction board that will replace plywood or gypsum. And we use this primarily in roofing, but it could be used in other parts of any construction.
Yeah, it's a really cool and I think innovative product. And I know you've made a lot of headway on this. It was sort of a long time in the making, but you know, over the last, 3.5 years or so, you've really kind of made a dent. And I think in an era where we're constantly talking about the environment and, you know, filled up landfills and we're trucking our garbage all over the place and where's it going to go? There's just so much need and a ripe opportunity, I think, if we can find a way to make this work. And we are going to get into the weeds on the product that you've done and how you've engineered it and all that. But I thought was really fascinating to me was just sort of where this whole thing started. And so let's just take a walk down memory lane a little bit and maybe take us back to the Kelly Waterbury Roofing Company and sort of that journey and how that's ultimately led to Kelly Green Products.
Well, my dad started Kelly Waterbury Roofing way back in 1946, and I was brought up in a roofing engineering company.
In one of those classic eras where the name told you everything. Kelly Waterbury Roofing. You know who, you know where, and you know what, right? Just from the name.
Exactly. And we did primarily commercial, low-slope, hot tar, built-up roofs, they called it. The stinky stuff. And on schools, high-rise buildings and manufacturing buildings, although we did some residential shingles, but that wasn't our real business. And we did a lot of subgrade waterproofing. So if you have a water table and 2 or 3 floors, which they have in big buildings in Hartford, and understand where the river is, okay? And the river's tidal all the way up to Hartford.
It is.
You got water situations that are going to come into the foundation, so we'd waterproof the foundation. So
with sort of the same tarring process.
Yep, hot tar and sheets of tar paper.
When you tell me about the tar and the sheets of tar paper, I got to tell you the first thing I think of is like Shawshank Redemption when they're tarring the roof. I don't know if you've ever seen that movie, and it's just like, man, I mean, it's just old school, right? Mopping some tar, spreading it out to keep the water out.
Yeah, at 500 to 600 degrees, you're mopping it, and you're putting papers in and mopping it again.
And what a long way we've come. So as that sort of faded away, what was sort of the evolution of the roofing business as tar kind of went out of favor as a methodology?
Well, then we started using synthetic membranes like a swimming pool liner of PVC or rubber and modified bitumen, and we changed over from making a road on the roof with gravel to putting these membranes down just like a swimming pool liner, and that's the transition. And today, it's 90% of the industry.
It's putting down that like rubber membranes.
Putting rubber and plastic membranes like swimming pool liners on your commercial roof.
Just out of curiosity, what is the real difference between why commercial does something totally different than residential is just because of the sizing of the roof, so there's not the same level of pitch to the roof? Is that why we don't do shingles on commercial buildings?
Yes, because a shingle doesn't work in this area unless you're literally on a 5 and 12 slope. That's you're raised up 5 inches to 12 inches length because water will back up, or you think of a snow load on the roof and then it rains on it and the snow becomes a giant sponge and it all just backs up under the shingles,
Got it.
you know?
So yeah, so for a shingle to work, especially if you're going to get a lot of precipitation, you really need a significant amount of pitch to keep the water flowing away.
Exactly. And if you don't, in New England, we get what they call the cold Cornish, where the drip edge of the building is outside of the heat of the building and it freezes. So you get this ice mass.
Yeah.
Okay. So we have to put literally a low sloped roof there, which is called ice and water shield. But it's membrane roofing underneath the shingles that when you put a nail through it, this membrane kind of like oozes around the nail and seals it.
Really?
So we do 3 to 6 feet of every edge now of residential has ice and water shield. Or if you don't, you're going to, when it freezes up, it's going to leak in the house right on the interior wall.
Right. That's where you get your ice dam, water backs up, and then you're going to get a wet wall right inside.
Exactly.
So how'd you get in the business?
I was born and raised. When the joke is, when I came home from the hospital and my mother said, "Here, you change them," I had tar on my butt. And born and raised in a roofing family, and my dad was educated in Chicago as a structural engineer. And we did structural engineering and subgrade waterproofing, and we did a lot of steeples and churches and commercial buildings.
So, what I've found is as people kind of get into a business, especially whether they take it over from a previous generation in their family or somebody else, they sort of start to take it a little bit in their own direction. And I feel like you did that a little bit with the business. So, when you came in, it was really all about roofing and looked more about installing roofs and managing the roofs. But you sort of pivoted, I think, more towards engineering roofing, right?
Exactly. Yes. We're one of the pioneers of what they call single ply roofing, or using rubber and plastic sheets instead of the hot tar. And
So you guys were early to that game.
real early to that game. We were one of the 3 pioneers.
And what was it about? I think everyone's always thinking about in their business, how do I make sure I don't fall behind, or how can I be the leader to be at the forefront of sort of the next kind of change? What made you want to get into this new thing? Why did you want to pioneer? How did you know it was the future?
Because the built-up roof, which we always used, couldn't take insulation that we're now using. I came into the industry at the end of the 60s, early 70s with the Arab oil embargo. And it was hard not only to get tar, but also to get gasoline. But now we all understood that we got to conserve the energy in the building, and we started putting high amounts of insulation into the roof. And so when you put a lot of insulation into the roof, the hot tar roof really in the summertime got so hot, it would stick to your feet, okay, with insulation underneath it. And then in the wintertime, you got freeze-thaw cycles. It would break it up. So the hot tar roof couldn't be insulated. They used to be right on the deck, and so in the wintertime, the heat of the building, you never kept snow on the roof. It just went right straight through. In the summertime, the heat of the roof, they opened windows in factories and they blew it out. So there was probably a thermal change of maybe 25 degrees between the top and the bottom. But now when you insulated it, it could be 100 to 125 degree differential, and it just destroyed the built-up roofs. So I was also involved in pond lining and pollution, and understood with Uniroyal, and we made pond liners out of the old inner tubes for tires.
Sure.
So we started making butyl pond liners so that they could put their pollutants in it.
Yeah, I don't think maybe some of the young people on this listening to this don't know what those ponds were used. I don't think we do this anymore. But what were they using? When you say pond, we're not thinking of a frog pond.
No, this was a commercial pond, so that instead of dumping your bad stuff in and polluting the Naugatuck River, okay, or any other river, or going to the ocean, if your waste coming out, you would capture that, and then you would have to process it. And microbes will eat almost anything. Think of oils and bad stuff. So you have it at the right pH and the right temperature, you can eat away most of your bad stuff, and then you run it through a purification filter and take the bad stuff out, and you have water that's actually drinkable stuff.
Just like in the cup, yeah.
Okay, drinkable stuff, or you evaporate the water, so you're controlling any pollution going into a pond, a stream, or the ocean.
So what you sort of learned from doing that ponding was like sort of the reverse of the roof, right? The roof, you got to figure out how to keep the water out. In the pond, you're trying to keep the water in.
Mm-hmm. But instead of having hot tar, now we can put these like swimming pool liners up on the roof. And so we pioneered a whole way of doing it. And how do you glue it? Or how do you like a shingle, nail it, attach it?
How do you do it?
So you either glue it or screw it, or you weight it with a whole mess of stone. And I came up with a whole neat process of understanding wind over a roof creates lift. And I got with some engineers at MIT, and I got a database of over 400 wind tunnel models, so I knew where the wind vortexes were. And in those areas, I could put a one-way valve where air would just come out from the underside. And as the wind blew over the roof, it sucked the air out from under the membrane and vacuum packed it to the roof deck.
Get out
just
of
like
here.
you vacuum pack meat. So our roof, we tell them, don't glue it, don't screw it, don't stone it. Let's suck it down.
Let's suck it down. So wait, let's just go through this. So you designed a roof that could be essentially attached to the building, just leveraging wind?
Yes. And that's why this became a very important aspect for us, because this weighs about 2 pounds per square foot, even more than a half-inch sheet of gypsum.
This being the recycled board product.
Yes. And we could put vast amounts of expanded polystyrene insulation in the roof and weight it in place with this board. Put the membrane over it, and just like meat in a package, vacuum pack it. So whenever the wind blew, it vacuum packed it.
But then do you need a certain positioning or amount of wind for this process to work?
Well, when it doesn't work, gravity takes place and it holds it in place. But when the wind blows, it's like putting, like in your bathroom, a vacuum fan to get the stuff out, get all the steam and the moisture out. It also dries out a wet roof, this process.
No kidding.
So we can go over an existing wet roof, put our process on it, and dry it out, because moisture, most people think you got to boil water to 210 degrees to change it from a liquid to a gas. If that was true every time it rained, we'd be dead.
That's right.
Okay, Boyle's law is all liquids are pressure sensitive to their vapor state. So what's a hurricane? It's a low pressure coming in.
Right.
When you listen to the weatherman at night, he bothers everybody with all these low pressures and high pressures. Okay, is it going to rain or is it going to be a bright sunny day? But low pressure over the Earth's surface causes the water in the Earth's surface to vaporize. And water vapor is lighter than air. That's why clouds are up there.
Right.
Okay, so that's
the thing. So,
it's all science that we just transferred into roofing.
So is there any scenario where this process could not be used to attach a roof?
None that I have found, but we have difficulty in freezer buildings where there's reverse osmosis. The cold is inside and moisture is drawn towards the cold, and when it hits that cold, it freezes and it expands.
Yeah.
Okay, so we have designs for freezer building where you have to bury a vapor barrier at the dew point, so this doesn't happen.
But other than that, any sort of commercial style, like I think they call it EPDM, right? Isn't that a kind
Well,
of?
that's what we really started putting down, EPDM roofs.
Got it.
And now the predominant is PVC, which is like your swimming pool liner type material.
Sure.
And another product like that swimming pool liner called TPO.
And so anywhere that there's a roof like that, you can put on. And so do you have, I mean, is this process sort of shared? Like, do a lot of people leverage this type of installation process?
Well, there's a couple that do it, but I'm the primary, and there's a resistance from the competitors because they now don't sell glues, screws, and all these attachment methods. That's where they really get their money.
So is this a less expensive, easier, and more effective way to put a roof on a building?
It sure is. We can usually cut the price at least 1/3.
Really?
And in re-roofing, sometimes we're half as expensive because we don't have to tear the existing wet roof off because we can dry it in place and save all the insulation that you have there that was wet.
So even wet insulation can sort of be dried out through the execution of this style roof?
Yes, because you're taking the low pressure of wind over the roof and putting low pressure into water, and water wants to vaporize in low pressure. Sometimes for demonstration purposes that shows, we have a vacuum chamber, and if you remember in basic physics and science in your lab in 101 chemistry, you could put a glass of ice water in a vacuum chamber and make it boil.
Yes, I do remember.
You remember that?
Sure,
Okay.
yeah.
So that's the basics of water in science. Low pressure will cause water to vaporize, literally boil.
Where did you get all of this sort of like science, pressure, experience, and knowledge? Is what we went to school for?
I went to school for it, but I had a dad that also taught in the state schools in the wintertime at Caner Tech in Waterbury and at Billard Havens in Bridgeport. And this was basic building science. And how do you dry out, your building when you're building it and you get all this moisture in it,
Well, it just seems so basic. That's really cool. Sometimes some of the coolest stuff, right, is just going back to the basics.
It's Science 101.
Yeah.
I mean, we're not putting a rocket ship to the moon.
Right. Although, speaking as someone who's owned buildings before and does still today, sometimes it does feel like it takes like a level 17 scientist to figure out how to get water to stay outside of your building. So, yeah, it's good to know. So let's kind of move to how you sort of pivoted to Kelly Green products. So you guys went from sort of Waterbury roofing to really working on this kind of new wind application with this new, rubber and plastic roofing. And then it seems like you looked for a way to kind of address the recycling. So maybe share with our audience, like, what was that pivot? When did it start? And where are we today?
Well, the pivot actually took place in the early 1980 to 1985, where instead of putting roofs on, we were like the project manager, engineer, the designer that designed these roofs across the United States. If a person blew one or two roofs off and was still the owner, he would then say, why am I putting the same damn thing on? Because the next big wind is going to happen.
Sure.
Also, things that affect, besides wind, are hail and sunlight that we get, and that deteriorates the single-ply membranes. You got to have sunlight resistance. EPDM rubber is almost impervious to sunlight. So it was a grand thing. But the PVCs had to have sunlight inhibitors and chemicals in it. So we pioneered in that science, but we always used our techniques of putting a roof on. And if you understand, a whole new concept is air barrier. You lose more energy in a building if the wall can breathe. So if you're hot on the inside and cold on the outside, okay, you're going to exchange air.
Mm-hmm.
And so like fiberglass insulation is really a lie in a wall, because hot air in the inside of the building goes up on the inside, but the outside is cold. So you get a convection of air going like this within the train. In that R19, you can't even get a 4 or a 5 out of it.
Got it.
Okay, so now today we do a lot of spray foaming
Yeah.
in the wall and get that building up to R32, R40. And on the outside, we do house wraps. Okay, and that house wraps stops the air pressure coming through, because most of the time the internal building is a different pressure than the outside, but you want to stop that airflow. And usually outside air has more water vapor in it, so you want an air barrier that's also a vapor barrier, so that you're not bringing it in and condensating in your wall with mold, mildew, and fungus. So it's a whole new science, because we now insulate and keep our energy costs down.
So it's interesting. So it's sort of, you just walked us through kind of like, I think, an evolution and just how the thought process of insulating a building goes, right? Because to your point that, like, you know, the often pink fiberglass insulation on its own doesn't really do as much value as we would think it does.
Well, it's rated for air conditioning. So in the ceiling, it gives you R19, because hot air isn't going up through it. It's cold.
Right.
And it's stopping the hot air coming through, okay? But when you reverse it and you got hot air inside, think of hot air going through fiberglass. You know, as I tell my contractors, you know, think of a fart through your pants. It's hot air goes up. Cold air goes down. You see?
Yeah, I got it. So the wrap makes all the difference. So, okay, so you're thinking about insulation, then where do we go from there?
Well, now we're able to use styrofoam insulation. And a lot of flat roofs also, the code changed and said, you got to pitch them. We've had enough of these ponds, and then the building sags a little bit, and you got ponds of water up on the roof, and they've just been a disaster. So the industry now says you got to have a 1/4 of an inch slope. So in 12 inches, okay, we got to have a 1/4 of an inch slope. So if you take a building that's 100 feet to a drain, okay, so what's 100 1/4 inches?
Yeah, that's going to be 25 feet. Yeah.
25 inches.
25 inches.
So
right.
now I got to have 25 inches.
Like 2 feet of pitch
at the edge.
Yeah.
Okay, all the way down to the drain. But they don't want that minimum at the drain. We've got to start out with 10 inches in the drain to get us an R40. So over at the edge, now we got 30 inches.
Right.
Or you got to put a whole bunch of new drains in and do all these complicated flows. Okay. So with styrofoam, you can do it very inexpensive, and trying to get a screw to go 10 inches into the deck. Well, what about 20 and 30? Okay.
Yeah.
And you're going to screw this. The industry standard is 1 every 2 square feet. So in a 32 square feet of a 4x8 board, you got 16 of these.
Yeah.
Okay. Now, if you put 16 fasteners in a 4x8 sheet, you lose 20% of the insulation with a thermal conductivity. But our roof, we put everything in loose, and we use the Kelly green board on top of it to weight it in place. It becomes the reverse ballast.
So you're putting the board on top of the roof?
on top of the insulation.
Okay.
And then we put the membrane over it, and we'll glue the membrane to the top surface, which is fiberglass, or we'll put the membrane loose over it
And use the wind technique.
and use the wind technology to vacuum it down.
And so thinking about how to do that is what got you to be thinking about how to make the green board?
Yes, I needed a board that was better than gypsum. So
What's wrong with gypsum?
one leak, it absorbs water, and you walk on it, it's like a wet sponge, but it goes smush. Take a gypsum board, leave it out in your driveway for one rain, and that's what you got.
And so let me just back this up. So we've got the new roof. We need to be able to have a pitch enough so we can drain the water. So you need to have sort of you need to sort of build it up to get the pitch you're looking for. You could use sort of styrofoam or some type of insulation to build it up. The problem then becomes now you're at some places you could be 2.5 feet from the top deck and you got to attach something to it. You need a very, very, very long screw to get all the way through that. So then the thought process you come up with is, well, let's flip this whole thing around. What if we put the insulation and then put another top board on top of it? So now I've got the pitch that I need, but now I've also got a flat, something I can actually attach my roof to that's right there instead of in some places 2 feet or more down. And all the products that exist currently, their main deficiency is if they get wet, then the whole thing disintegrates. That's a problem.
It is, and in New England, we go through freeze-thaw cycles.
Sure.
So where the heat of the inside doesn't get to it, although insulation or gypsum board goes through a freeze-thaw cycle, and now it is dust. It reminds me of my mother's old joke.
What?
Johnny came down to the kitchen table on Monday morning and said, "Mom, is it true what the preacher said, that we are dust, and to dust we shall return?" "Oh, yes, that's in the Bible. Jesus said that." "Oh, Mom, you better come upstairs and look under my bed. Someone's either coming or going."
From dust to dust.
So
we've got
the roof
that.
started out with dust, and it shall be dust
again.
And
So how did you think to do the board from recycled material?
we met. I got a friend in Des Moines, Iowa, and they were making a board for the wall, trying to do this out of recycled materials. Now, they never got any code approvals, and I knew what I had to go through to get code approvals. So in the code, they have a big block of wood with many things that last for a fire for about an hour. So if you had flaming debris, like the stuff that happened in Maui,
Yeah.
okay, for a commercial building, a Class A, you got a 1 foot by 1 foot block of wood that they burn for an hour. And then they let the 12 to 13 mile an hour wind go over it for another hour to see if you got some
Reignite.
punking or something.
Yeah.
And can the fire get through and inside the building? So gypsum was the natural product that you'd put there because we have firewalls. But I found that I knew fire retardants from what we put into membranes on the roof on EPDM. I was the first to have a fire retardant EPDM in the industry. So we put the fire retardants into this whole slurry, and we can make a fire retardant board that's equal to gypsum but doesn't absorb any water. Believe it or not, your juice cartons and your garbage bags have antifungicides in it, so the bugs and mildew and fungus can't go. So it becomes a much better board than anything else that we could use as a weighted board. So that's why I went off for 3.5 years developing this. And believe it or not, we finally got our 24/7 shift working, and we're making board finally
Finally.
finally cost effective in Waterbury.
And so is the board itself cost effective in the context of the roof to be able to do it this way? Because I know we talked about this before, so I'll bring it up now. But it is not as easy as one might think to just get good quality garbage to turn into a board right away.
No, so sometimes we have to mix it. Okay, and some of the garbage that we get are literally reused milk cartons, and they smell like spoiled milk.
Yes.
Okay, we get anything that came in a carton. Okay, ice cream cartons, pizza boxes, juice cartons, orange juice. It smells better, orange juice, when it's left over. But we also get a lot of new cartons that either were printed wrong or they didn't have the run on that type of juice. And
So it's almost like pre-garbage. It's like it's like in the production, right? It never been used.
It never been used, and we can see a piece like right here.
Yeah.
And these are big ribbons that feed through a machine that make the carton. And so we mix that also in with our carton material. And we've been able to use other plastics besides just the plastic bags. Any low-density polyethylene, we put it in, and it mixes well. We've been using some fire-retardant polyesters and other plastics. As long as it'll mix in, we're able to use it.
So how's it going?
Finally, after 3.5 years of being non-profitable, we can now make a board that can compete with plywood. Cost in the field, the same cost that you would pay for 1/2-inch plywood to put your roof on. That's what we make the board for.
And so what's been the market sort of response at this point?
It's like, what is it? Who's used it?
Yeah.
And we have all kinds of government facilities, schools, airports, Tesla battery factory. All of a sudden they see it. Target stores, sometimes the old Kmart. Kmart had used it before they went out of business. But we have a track record of over 6 years of using this kind of a board in the roof. And it's much better than the gypsum products that guys use on a day-to-day basis. Their objection to it is that it's heavier. That's what we want. But also you can only cut it with a saw like you do plywood. Where gypsum, you can take your knife, crack it, and it's much easier.
So what you said you want it to be heavier. Why is that?
Because we use it to weight the insulation in place. If you had less weight and if you had some moisture in the roof, insulation will warp or cup. Okay? This keeps it from warping and cupping even if you drowned it.
Got it. So you think it's a bit, yes, it does weigh a little bit more, but you're going to get a better result from it.
Exactly. Now, another benefit that people are starting to see is that it becomes a walking surface for traffic across the roof. Where if you're walking on a membrane on insulation, you get a rut in there. It's just like, if you walk through a field or you walk through the forest, okay, you compress it down and all the roots come up. But what it is the fasteners start working their
back up.
And the cover board really helps. Now, in areas where hail comes, when hail hits the single ply membrane, it's like a catcher's mitt. Bam!
Yeah.
And it'll stretch the membrane in a cold. When hail first comes, it's small stuff and it's cold rain. It's like taking a 7-Eleven Slurpee and you put it on the roof. So now you're chilled down into the 30 degrees. And you whack it with a golf ball size hail, okay? And it dents in. It makes spiral target cracks in the membrane. if you have this hardboard underneath it, it implodes the hail.
Wow.
Okay, so, and it's also people walking across the roof. You walk across a plastic roof in the wintertime, your heel, what's it doing?
Puncturing through, yeah.
Okay, so you can get cracks from that, or if you had to work on the roof. But we have this hardboard underneath it. Nothing happens to the membrane.
So it just sounds like a really, really innovative product that could change in such a positive way the roofing industry. What's your strategy at this point to get this thing more out in the market and more broadly accepted and used?
I'm not going to go big like the big boys that, build a gypsum plant or a plywood plant. I want to build a 3-machine plant in every major metropolitan area so that I'm using their recyclables, their garbage. And it's controllable enough that I've got input there and we're putting on roofs in that area. So I have 30 locations across the United States that for $10 million I can put in a 3-machine plant that makes about 20 million square feet to feed the area. With that, I'm not even 5 to 6% of the need of the industry. So I stay under the wire or the big guns in the industry, and I stay small, but I can have the quality and the market that wants this.
There you go. That's fantastic. And you've got it already up and running in Waterbury.
We finally got it up and running, and now we can say, hey, the model works. It's profitable. And now we can just repeat it over and over.
Would you for like a franchise type of an approach where the local person sort of owns it and runs it in that market, or are you going to try and run them and build them yourself?
I'd be looking for partners throughout. The machine is a big iron. It's a stupid big iron, and people have to run it, and you have to clean it. And people control is what it is. It's not something that's going to be fully automatic. You just can't do it. It's stupid technology.
Okay. You love going back to basics, Tom.
Well, it is. It is basics, and people have to run it. And you want to be small and controlled within an area so that you're using everything that's there. The other thing that really hurts everybody in the industry is shipping costs.
Yeah,
Where shipping costs are today. When we have to ship more than 500 miles, okay, we're out of competition.
Mm-hmm.
You got to be within like 300 miles of what it is that you can even compete. But think of every major metropolitan area throughout the United States could support one of these smaller plants, and you're using local people, you're using local garbage, and you're helping the local economy, and it makes a whole mess of sense.
Listen, man, it sounds great. I am looking forward to watching this grow. I know you've done so much legwork. Feels like this has sort of been the natural culmination of, your whole entire career. It's really impressive.
I thank you very much. Yes.
Well, listen, I'm going to flip to some final questions and we'll wrap it up. You ready?
I'm ready.
All right. Do you have a favorite business book, Tom?
I can't say, there's so many of them,
Fair enough. Hard to pick a favorite.
Yeah.
Well, how about this? If you had to do something other than run Kelly Green products, it could be anything in the whole wide world, what would you do to pass your time?
I think I'd like to see if I could get employed with the UN and see if we could interest people in the world to take up the UN Declaration of Human Rights. I think that's our biggest problem in the world. We are into our own country, right or wrong, where we are all the same. sons and daughters of God.
Yeah.
And we don't extend our rights that we expect amongst ourselves to the same people outside of our territory. So there's a Declaration of Human Rights that Eleanor Roosevelt pioneered in the UN. And I think if the world could accept that, we wouldn't have to go to war.
Be a much better place.
Yes.
Well, that'd be a very honorable thing to do, Tom, because you're passionate about it.
I am. I even get a tear.
Yeah. Well, listen, man, I amen to that. You know, the golden rule take us a long way. If we could just, going back to the basics, if we could just get that done. You've done a lot in your career. What's something that you've learned early in your life or early in your career that you think's helped propel or springboard you to all the success and innovation and pioneering that you've achieved?
Doing it right. You know, you just don't do it for the money. Do it right and make it better. There is good, better, and best, and show people that it is. There's some people that'll only buy good or okay. They're going to be cheap, and you know what? No problem. We'll be back 10 years after that's a disaster. Now, if you want a 20, 30, or a 50-year roof, it's real easy. And it's not more than 10, 20% to do it. Okay? And we got a track record to show you and prove you that you can do that.
Oh, that's really cool. What's something, Tom, that you learned later in your life or later in your career that if you could go back and tell young Tom, and if he'd listened to you, you think it'd have a real positive impact on his life?
Follow the golden rule with everything you do. And try to be the best and bring people along to the best.
Amen to that.
Amen to that.
Tom, thank you so much for coming on, sharing your story, sharing your thoughts and your beliefs. I really, really appreciate the time.
Great. Thank you very much, all of you.
Made in America with Ari Santiago is brought to you by CompassMSP.
Thanks for listening and spending some time with me today. My goal is to help build a strong manufacturing community, and it would be impossible to do without all of you.